So in this video, we're going to be looking at QRS and QT intervals, but first we'll just go back to the ECG that I left at the end of the last video. So we'll start off with the rhythm. There's my mouse. Okay, so we have a QRS complex here, maybe 2 small squares, 3 big squares, 1, so maybe 3 big squares and 3 small squares, and 3 small squares, 3 big squares, maybe 4 small squares, no, 4 small squares, and then just a little under 3 big squares there. So it's a regular rhythm. It's a regular rhythm. We have normal and we have equal R to R intervals. Next, we can look at the actual rate itself. So let's try and find a QRS that actually falls on the line if possible. That one, we'll have to take this one, it's close enough. So we have a QRS there, and then just below, just shy of 4 big squares. So I'm happy with that. I'm going to call that 75 beats per minute. So 75 beats per minute, and it's regular. Next, what we're going to do is we're going to look for P waves. It's chosen V1 as the rhythm strip. So we can pretty much see that there are P waves. There's a lot of them. And how many for each QRS complex? There are 3. So 1, 2, 3 QRS, 1, 2, 3 QRS. So there are 3 P waves for every 1 QRS. And if we look at the P waves, the atrial rhythm, so the rate of the P waves, is maybe just slower than 300 beats per minute. So we have 300 beats per minute as an atrial rate and 75 beats per minute as a ventricular rate. So this, as there are 3 P waves for every 1 QRS, we call this 3-to-1 conduction. So atrial flutter, because we do have these sawtooth flutter patterns, atrial flutter, and it's a 3-to-1 conduction. So we're happy with that. So the correct answer was atrial flutter. So now onto the intervals. So starting off, we're going to start with the QRS interval. So what we're really looking for the QRS interval is it a narrow complex rhythm or is it a wide complex rhythm? And this can be very important, especially in acute scenarios. Say if you're in the emergency department and someone's come in acutely unwell with a tachycardia, you really need to know, is it a narrow complex tachycardia or a wide complex tachycardia? Because the treatment will be radically different. And that's very important. So here we can see that it is shorter than 120 milliseconds. It's something that you can do very quickly. So if we remember, 1 big square 200 milliseconds, 1 small square 40 milliseconds. So all it has to do is be shorter than 3 little squares, shorter than 120 milliseconds. And then moving on to this one, and we can see quite a wide complex tachycardia. So we can take multiple of these, but we can see that that is pretty wide. It's maybe 3 or 4, I'd say 4 small squares. It's going to be about 160 milliseconds. So we can say that this is a wide complex tachycardia. The reason why this is important is that if there is a wide complex tachycardia, it may be coming from the ventricles, and there might be certain medications that, if given, can lead to life-threatening arrhythmias. We'll cover this in later videos. And so the next thing that we're going to look at is the QT interval. So we calculate the QT interval from the start of the Q wave, which is here, until the end of the T wave, which is here. Some people like to draw a line, a tangent, to calculate where is the end of the T wave if it's unclear, but we're not going to overcomplicate things today. So after we've got the QT interval, what we actually want to do is calculate the QTC, which is the real QT interval, the corrected QT interval. When you get an ECG, it almost always calculates it for you, but it's really important to actually calculate it yourself. So the way in which you do that, you take the QT interval and you put it into a formula called, what we'll use is the Bazet formula. There are a few formulas, but you can find them online on MedCalc. That's what I always use. And so after we have the QTC interval, we can then compare it to standard ranges for males, which would be 350 to 450, and in females, 360 until 460. Now, if we had a shortened QT interval, then you might be thinking again about the potential causes such as hypercalcemia, also hyperkalemia. Alternatively, if it was a prolonged QT interval, then you might be thinking about hypokalemia, and there are various causes of hypokalemia. You see it in losses, so with diarrhea, with vomiting. You see it with malabsorption, such as in pancreatitis, in alcoholic liver disease, and you also see it with certain drugs such as diuretics. But as well as hypokalemia, it may also be due to drugs such as antibiotics, antifungals, antiarrhythmics, antidepressants. So there's many drugs that can cause prolonged QT interval. And rarely, it might actually be part of a syndrome called long QT. You can get syndromes of short QT, you can get syndromes of long QT, but they're very rare. And they're both due to channelopathy, so mutations in ion channels in the heart. So this is the reason why we get worried about a prolonged QT interval. It's because it can degenerate into life-threatening arrhythmias, and this is probably the main one that we're going to be talking about, torsade de pointe. So it's twisting of the points. And this is a polymorphic ventricular tachycardia with a prolonged QT interval. And so this shows you the Bazet formula. So the Bazet formula you can use to calculate the QT interval. Typically, you use this in sinus rhythm, so from 60 beats per minute to 100 beats per minute. If it's very bradycardic or if it's very tachycardic, then it's not such a good estimation of the QTC, the corrected QT interval. But generally, we can use the Bazet formula. So here is the practice ECG, so have a go at this one and we'll discuss it in the next video.
Oh yeah, I saw for a while by oh yeah, I saw for a while by twist me as well, twist me as all for, oh Julie.